In this example, we're going to look at the properties of rational exponents, and we are looking at the example 8w to the negative 1 power times z all over 2w times z to the negative 3, all raised to the 1/2 power. So, before we get started, remembering our properties of exponents, if we have an entire parenthesis being raised to an exponent, we could give that exponent to every aspect inside of that parenthesis. So that's what I'm going to do first. So that means this is the same as saying 8 to the 1/2 power, w to the negative 1 to the 1/2 power, z to the 1/2 power, over 2 to the 1/2 power, w to the 1/2 power, and z to the negative 3 to the 1/2 power. Notice that I just gave that 1/2, that exponent, to every part of my problem. And if my variable already contained an exponent, I put it in parentheses and then raised it to that exponent again. What that means is that if we have an exponent raised to another exponent, we multiply those two numbers together. Okay, so I have 8 to the 1/2, and then w to the negative 1 to the positive 1/2. We multiply that together, and we get w to the negative 1/2. And then z to the 1/2 over 2 to the 1/2. W to the 1/2, and then z to the negative 3 to the power of 1/2 means we multiply, so this is z to negative 3/2. Okay. Now that we have all of our exponents simplified, we need to get rid of all the negative exponents. And we're going to get rid of all the negative exponents by moving them to the opposite side. So if it's on the numerator, we're going to move it to the denominator. If we're on the denominator, we're going to move it to the numerator. So for example, this w is going to move down, and this z is going to move up. And when we do that, the negatives go away. So this is 8 to the 1/2, z to the 1/2, z to the positive 3/2 over 2 to the 1/2, w to the 1/2, and w to the 1/2. Okay. Now we are going to combine like terms. So for example, in the numerator, we have like terms of z. In the denominator, we have like terms of w. So when we have two exponents with the same base being multiplied to each other, we add the exponents together. So we have 8 to the 1/2 times z to the 1/2 plus 3/2. We're adding these exponents together. And then 2 to the 1/2 times w to the 1/2 plus 1/2. When we do that, we get 8 to the 1/2 times z to the 4/2, which is 2. Okay, and then 2 to the 1/2 and w to the first power, because 1/2 and 1/2 is just 1. Okay. Now that we just have our numbers being raised to those 1/2 exponents, we can remember that when we are raised to a rational exponent, the denominators of those exponents tells us our index, and the numerators tell us our exponents. So technically this 8 to the 1/2 is the same as saying the square root of 8 raised to the first power but we don't need that first power there, okay? Same with the bottom. This is the square root of 2 raised to the first power, which we don't need to write, w. Okay? So now we just need to see if we can simplify our radicals to see if anything can cancel out, and this is our last step. So we know 2 can't be simplified because 2 is prime, but let's check 8. So I'm going to write 8 off to the side, and I'm going to do the prime factor tree. So I have 2 goes in 4 times, and then 2 goes in 2 times. Since I'm talking about the square root, I need pairs of 2. So that tells me that the square root of 8 is the same as saying 2 square roots of 2. So I'm going to plug that in. So 2 square roots of 2, z squared, over square roots of 2, w. My square roots are going to cancel out. And then I have 2z squared over w. And that's my answer.